Hey everybody, this is Alex Merced from alexmercedcoder.com, and this is another JavaScript potpourri where I'm just going to go over a bunch of random neat things you can do in JavaScript. So I'm just going to open up my testing.js where I generally do this stuff from. Let's just get back up to the main folder. There we go. Cool. Let me just clear out the terminal. Neat. So first I'm going to just talk about this. So let's say I did this. X equals, and then I do in parentheses, 5, 4, 6. Basically what you can do is you can actually chain different expressions, but the assignment should only be the expression at the end of the parenthesis. So in this case, even though I do 5, 4, 6, technically what this will do is assign 6 to X. Which seems silly, but I'll show you some uses for this. Console.log X. Okay, so let's just show you that. Testing or node testing.js. See, 6. So how can we make this more interesting? Okay, so let's do this. Let's do y equals 5. So y is 5. So let's say first we want to increment y, then we want to increment y again, and then we want to assign y. Okay, I mean I could have just done y plus 2, but again, the idea is maybe we have some more complicated things we're doing. Okay, so there we go, 7. Other thing I could do. Okay, so let's say y, and then we'll say z is 3. Okay, so we'll say y equals y plus z, y plus plus, then y is what we assign. So basically what I'm saying here is that we're going to say, okay, y equals 5 plus 3, so that's going to be 8. Then we add 1 to it, which makes it 9. We're going to assign 9 to x. So let me save that. So the result should be 9, if I'm thinking this correctly. Yep, 9. So that's just a neat thing. Okay, so you can create some interesting situations that way. Far as getting an eventual assignment, so you can actually chain so basically in a situation where you couldn't really chain a bunch of expressions together, you could just kind of create this parentheses around the different expressions. So basically expression 1 will resolve, expression 2 will resolve, and then the assignment will occur on the third. That's a thing you can do. Cool. That is neat. Let's go talk about template literals again. You know, a lot of stuff I'm gonna have covered before, but we're doing it in one video. So again, what's a template literal? That's when you have a string that equals backticks. Okay, and the cool thing about backticks is that now I can do stuff like this. I can do hello, my age is, and then I can just put that in there, and I can put any kind of JavaScript expression I want in there. I can put a variable, an expression. So again, I can just do something like this. I can do 30 plus 4. Okay, so that expression, what's going to happen is that whenever these expressions pop up, the expression will be resolved. So this 30 plus 4 resolves to 34. So then it becomes hello, my age is 34. So if I were the console.log x, okay, let's see what we end up with. Hello, my age is 34. Okay, so this allows us to do all sorts of really cool dynamic stuff. Neat. So that's neat. Now, another cool thing you can do with template literals is you can tag them. Okay, so I can create a function, const tag equals, and basically you always pass in 2 arguments. The first one is strings, which is going to be an array of all the strings. So technically this would be the only thing in the array right now, the strings array. Now, then every expression gets passed in as a separate argument. The way you capture all those arguments is you do this. We'll use what's called the rest operator, which will capture all other arguments going forward. and we'll just save it in a variable called x for all the expressions. Okay, cool. So I'll do that. So strings and expressions. What was it complaining about? Oh, I didn't finish defining the function. So let's keep doing the function. Again, this is an arrow function. It doesn't have to be an arrow function. Cool. Now, if I do that, then what's going to happen is we'll just console.log string, so you can see the result of these arguments. Console.log expressions. And then what you do is if you want to use this function on this template string, you just put the name of the function right before it, and it tags it. So then what happens is that this string gets torn to pieces. So each part that's just a pure string, so basically what it'll do is it'll read this, stop there, add it to this array. Then it'll take this, and then add it to this array. And then it'll just keep doing that back and forth, breaking down the string. Okay, so see, hello, my name is 34. Right now, x doesn't equal anything because I didn't return anything. So let's sit here. Let's say I only want to return expression, the first expression. That's all I want this function to do. So technically, what I'm going to end up with is just 34. Okay, see? So essentially, what happens here is that this becomes a function expression. There are very unique situations where you may want to actually use this. I think what's more useful is something that's not actually officially in JavaScript yet, which are decorators. Decorators will work pretty much the same way, except that you create a function, and then what you would do is let's say you would just take anything, like any variable. So let's say const z equals whatever 5. I would then be able to do like at tag. This decorator would then be the name of a function, and then would just pass this value into that function, which you can then use it to decorate a class, decorate another function, decorate a, there's a lot of cool things you can do with it, but right now it's not officially in JavaScript yet. You can use it in TypeScript, and you could use it in JavaScript if you use like a transpiler like Babel, but still not quite there yet. Although I hope they add it sooner than later, because it is actually really cool. But right now, no browser supports it. So there's a couple other really cool things that they're planning to add down the pipeline. Like there's, I think, another like operator for like chaining functions. But we're not there yet. Cool. So that's cool. One other cool thing you can do with like strings is use the eval function. Okay, what the eval function does is you pass it a string, and it just treats that string like you're writing JavaScript. Okay. This can be useful for when you want to do kind of Mad Libs code. So you have a block of code, but you want the user to pass you in a bunch of variables. So, so in this case, we'll just kind of show it console.log. And then here I would put in, let's say, 30 plus 4. There is no x, so remove that. Okay, so what this is going to do is when I run this code, it's going to evaluate this string. First, this gets resolved, so that becomes 34. So now it just says console log 34. It evaluates it as if it's JavaScript. And ta-da! 34. This is really useful for making calculators, because then you can just construct a string with your formula. So, you'd sit there and figure out, like, okay, what's number 1? We'll say, num1 is 5. We'll say we had a variable that was the first number that someone enters in the calculator. And then they said, hey, they want to add. So then they would, like, include, the plus operator in your formula. And you just build this formula. You just build this string using your calculator and then throw it in the eval function. And it would just run that. Okay, so that would be like 5 plus 6. Now I'm going to console log that. So let me just do that. And essentially what it's running, it's going to first evaluate all these. So it just becomes a string of 5 plus 6. It's going to console log 5 plus 6. 5 plus 6 is 11. Okay, this is very useful in creating sort of dynamically generating code to be made. So like basically you have code that you want to run, but it depends on a lot of other factors. So what you can do is you can build your code as a string and then run it through eval based on all those variables that you don't know yet. And then you can use string interpolation to inject all those variables into your string. Cool. That is very nice. You can have dynamic class names that way. It's pretty cool. Neat. So I think that's a good visit on strings. Let's go revisit destructuring. So again, destructuring, what is it? It's just a way to break down variables. So const my array equals 1, 2, 3, 4, 5, 6, 7, 8. So if I wanted to take out some of those numbers from that array, I could do this, const, and then what you do is you create an array, and that tells JavaScript that you're destructuring an array. So we're going to store the first number in 1, store the second number in 2, and then the rest of the numbers we use the rest operator, which means to grab the rest in the rest. And where am I getting these numbers from? My array. So basically what array reads is it takes a look for the first element in the array, 1 goes here, second element in the array, 2 goes here, and then the rest, 3 through 8, will be parsed as an array and put into here. So now if I console log that, now I can console.log 1, 2, the rest, because they are now freestanding variables. Cool. That's neat. And then I can even change your names too. Well, actually here, that's well, I don't really need to do that here, but yeah, that's pretty good. And I can also do this with an object. So I can do this like so. Name Alex Merced, age 34, email alexmerced at alexmerced.dev. Cool. And then I could do this kind of the same deal. We'll just change this to my object, so it's all semantic and stuff. My object. Except now we're going to use curly brackets to deconstruct the object. Okay, so in this case I'll be like, I want the name variable, I want the age variable, and I want the email variable. And it just saves those in 3 variables separately. So like now I can console log name, age, email. Okay. And ta-da, it works. Now if I wanted to change the name of a variable, like I don't want it to be called name, but I want to pull name, I can just do this, name, and we'll call it cheese. So now, if I console log cheese, it should just still show my name. See, it still works, because cheese, we're just saying, hey, pull the name property, but store it in a variable called cheese. Or let's say there's something called like, you know, my B year, my birth year. But there is no property called birth year in this object. What we can do is we can name a default. So we'll just say 1985. Okay, so basically if it doesn't find the property, it will just assign it 1985. So B year. And let's watch it work. And there we go. Okay, now if there was a value, so if I did add a value, so let's just change my B year to something else. 1986. I'm actually born 1985, but as you can see, it will override the default value. And there you go. Okay. So that's pretty cool. So that you can do a lot with that in a lot of situations. Very nice. Cool. And you can literally, anytime you pass an object or an array anywhere, you can use destructuring. Yeah, it's just super awesome. Cool. Then there's a ternary operator. So I can be like const cheese. And then we'll say, hey, if 5 is greater than 6, which it's not, we use a question mark, which means if this is true, do this. So then we'll just say it equals Gouda. If that's not true, it equals provolone. Yeah, I never 100% sure how to spell provolone, but we'll let it go. Okay, save. So basically, this is called a ternary operator. So basically, if this is true, which it isn't, it would assign Gouda. If it's false, it'll assign provolone. Or basically, it'll just run whatever expression is here. So basically, if true, do expression 1. If false, do expression 2. Okay? And then assign the result of that to this. It doesn't have to be used for assignment. You can just run these as sort of inline if statements. Now if I do no testing, see, you get, oh, I didn't console log it, so we don't know what happened. Console.log cheese. And there's provolone. Now if we switch this to is 5 less than 6, which is true, now it'll be Gouda. Cool. Now when can this be useful? This is especially useful when you have variables you're not sure exist. So for example, let's say I have a variable called Gouda. Okay, and I want to actually make cheese equal what's inside the variable Gouda. Now if Gouda exists, because if I never made a Gouda variable, it's going to be undefined or null, which resolves as false. So in that case, if it is there, it'll just assign whatever's inside Gouda. Okay, but if the variable doesn't exist, I can use this as a default value, so provolone instead. So right now, Gouda, again, I never defined Gouda. So in that case, I just go boop, boop. Gouda is not defined. Oh, you are complaining. Why? Okay. Well, usually that should be fine, but I guess it has to be. It's more useful when there's like an object. So let's try this. Const my obj equals, okay. Now I have my object, but I'm not sure if my object has a property called Gouda. Okay, so I would do my obj.Gouda, and then if it's there, then I would assign my obj.Gouda. I guess top level doesn't work that way with top level variables. Okay, because you're gonna find this used a lot when you're dealing with a lot of object properties and you're not sure if they're always there. Okay, provolone. See, just says, okay, my object.Gouda doesn't exist. It's undefined. Now if I sit there and I go in here and I actually put in a property called Gouda, and we make it the string Gouda, I hit save. Cool. Gouda. So this is useful to test whether a property exists, because sometimes you may, especially when you're doing like API calls, the data is there 1 second, it's not there 1 second, then it's there later on, but your code doesn't know that it's coming. So your code might be checking for an object property that doesn't exist yet because the data hasn't gotten from the API, so it's running into errors saying this is not defined, this doesn't exist. So doing a test like this, it says check this if this property exists, and if the property exists, then do something. If not, do something else. Even if it's just passing a null string, will help you avoid that error and get through. So this is a very useful pattern if you don't already use this. Okay, essentially you can use this anywhere you would use an if statement. Cool. So that's the ternary operator. I'm trying to think what other really fun ones are there. Spread operator is always a lot of fun. One of the big reasons to use the spread operator is to, well, you can really use it for anything, especially like a lot of weird objects. Like JavaScript has a lot of objects that are not an array, but they may look like an array, like a set. Okay, so if I were to sit there and do const new set equals a new set, and the way a set works is that you pass in an array. So let's say 1 - 1 2 2. And notice there's duplicate numbers in here. Sets have to be unique, so everything in a set has to be unique. Okay. So now if I console log the new set, see it's a set, but notice, see, it's not square brackets, so it's not an array. So I can't go like new. There's no way for me to access each of those elements individually. I can iterate, like I can use a for loop over the set. So if I want to iterate over this unique set, but if I want to do all those array functions or just use one item at a time and use like an index to grab it, I can't do that. So the way you would do that is you have to turn it back into an array. Now, how would I turn it back into an array? Here is the trick. So what you do is you want to say, we'll say my unique array. So basically the idea is I'm taking this array and I want to get rid of all the duplicates. I'm going to say it equals a new array. So I'm going to use square brackets. That means new array. And inside that array, I'm creating a new set, but I want all those but if I just do this, watch what happens. Okay. Console log unique array. All I'm going to end up doing is having an array with a set inside of it. That's not what I want. Well, unique array is not defined. Where did I spell it differently? Oh, that wouldn't, spelling matters. Cool. So yeah, now I just have an array with a set inside of it. That doesn't really help me. So the spread operator will tear apart that array into individual items and put them in the array. And now I've removed all the duplicates and put it back into an array, so I can work with it like a normal array. So usually that's how sets will be used. You just use them as an intermediary to remove duplicates. So you just kind of do this exact pattern here, and just all the duplicates are gone. And put into an array. Very nice. But again, spread always just all it does is break apart the object. So you can do this with any object. Or array. Okay. Instead of, just literally just does what you just saw. It just takes the item, breaks it up so that way it becomes individual elements in the array instead of the whole collection as an element in the array. The other really useful use for this is making a copy, because here's the problem. If I do const my array equals 1, 2, 3, and then I want to make another array that's the exact same thing, const, my r2 equals my r. The way arrays and objects work is that they're passed by reference. They're referencing a spot in memory where that data exists. So technically I'm not passing the data to my array2, I'm passing like the address of where that information exists. So now if I were to change array2, my r2, so we're going to change the first element, which was 1, we're going to make it now equal 5. But if I were to console log the original array, my r, let's actually console log both of them, my r2, save, you'll notice that they both changed. See, now they both have 523, 523, even though I only made the change to 1. Okay, because they're technically the same array. Both variables have the address of where that variable exists. This is why when you pass an array or an object to a function and you mutate it inside your function, it actually changes the original variable. While if I were just to pass in a number or a string, when strings, numbers, or booleans get passed in, they actually do make a copy. So when I edit it inside the function, I'm not editing the original. Okay, so, and again, that's an important distinction because it affects how you're going to do certain things. Cool. So let's see here. My array 0, my array equals 5. Cool. So now let's say, but what if I don't want to change both? I just want to change my array 2. Well, then I have to change how I do this. This is where the spread operator becomes really useful. I would then again put square brackets around it, which means new array. But the problem with that is if I do that, I'm only assigning the array as the first element. So watch what happens. Okay, see, this only has 5 because it only had one element to begin with. I assign this whole array into that array, and then into the first index of 0, and then I replace the first index of 0 with 5. So now my array 2 only has 5 in it. That's not what I wanted. So I'm going to actually spread these elements 1, 2, and 3 as separate things. So I use the spread operator. Save. And now, there we go. 5, 2, 3 in my array 2, but the original my array is unchanged. So the spreader operator is a great way to make a copy of an object by spreading it when you make a copy, so that way you're not making a reference to the original. Okay, because basically you're using the square brackets, which means make a new address, but then you're getting the same exact build by using the spread operator to spread the original item inside of the new array. So that's very useful. Okay, quick again revisit down like old functions, new functions. So again, old function syntax is this function myfunc cool, and then we'll just say console.log hello, and then basically what you would define the function, and then you can do myfunc equals, or no, myfunc, and then we just invoke the function. Cool. Hello. Okay, then you can just make functions that do whatever you want. Now, there's a couple weird nuances of the older functions. These older functions always had an object attached to them called the prototype. So whenever you would use these functions, if I were to use this dot variable equals 5, okay, this dot variable equals 5, then what happens, and then now we're the console log this dot variable. Let's do two situations. Okay. Let's see how this works. I'm not sure if that's going to work the way. Yep. Yeah, it'll just console log that variable because it belongs to the function. The function actually has its own attached object. So this will always refer. So what if I had another function inside of it? Function myfunc2, and I want to console.log this dot variable. This should end up with confusion because this now refers to this function's object, not this function's object. Okay, so if I do that, I should end up with a weird error that this variable is not defined. Okay, see, I only console logged once. Oh, because we never invoked the function. So let me do that first. myfunc2. So basically what happens here is we define the function, we invoke that function, and then this function creates another function and invokes that function. Okay, feel free to pause if you just need to take a look at that for a second. Okay, still worked. I'm trying to think through why that would still work. I guess because this would be the prototype of that. Okay, but let's try this just to show you that they do have two separate objects. This dot variable, sorry for the sirens in the back, I live in a busy part of Brooklyn. This dot variable equals 6. Okay, and then what I'm going to do is after this function runs, we're going to console.log this dot variable again from the, but we're back in the parent function. Why is there two parentheses? Okay. So essentially we should see 565 now. Why? Oh, I see why, because I invoked the function afterwards. So let me do this, Control X. The function gets invoked there, so I really want it to be 565. So save. 566. Interesting, that is not behaving the way I would expect it to. Let's think this through. Because this technically should have its own thing. Because it's old school function. And this is where the this keyword gets really confusing with the old functions, because you never know what this is, depending on the situation. If I use like an arrow function here, like if I made this an arrow function, this would definitely be this. Which is why everyone uses arrow functions now, because the arrow function doesn't have an object attached to it, so there is no this. The arrow function is just a function. Now, if the arrow function belongs to an object, you could refer to that object using this, but it doesn't have it. It basically, this belongs to whatever invoked that arrow function. It doesn't belong to the function itself, because basically what happens here, the old school functions did double work as classes. So I could be like function dog, okay, this dot name equals Sparky. Okay. This dot bark equals, okay, and then we'll just do an old school function just to kind of see if the problem I was trying to illustrate happens. Okay, function console.log stop barking this dot name. Okay, stop barking this dot name. Save. Okay. So even though this looks like a function, I'm able to use this as a class. Like watch, const Sparky equals new dog. Okay, and then when I hit, now we say, you know, Sparky dot bark. Save. Sparky's gonna bark. Stop barking Sparky. So it still works. And again, it's unpredictable when that situation happens where the thises don't match. So you always got to be careful for that. And you'll see, like, there's situations where when you use the old school function syntax within the old school function syntax, this doesn't always quite translate right. This is why, like, when you're using like React class functions, you used to have to use that bind function to bind this. So that's why eventually like they broke this apart. They said, you know what, this is confusing. Functions can work as functions and classes. So how about this? How about instead we just making classes that way? So it'd be class dog, and instead we'd put all this logic inside a constructor function inside the dog, because that's what most languages would do. Okay. So hit Control X, we would put this here, and then here I don't need to do that. I would just do this. Okay, and this would basically be the same thing. It's literally the same thing as that function before. Okay, it'll work just the same. So if I hit save, I do this, and see it keeps working. But if I were to make this an arrow function, which is what I should have done first, it wouldn't work. So let's turn this into an arrow function. This so this dot bark equals, we'll just make this an arrow function inside the arrow function. And then we'll just say const dog equals. So now I've translated it into an arrow function. This will not work because it is not. See, dog is not a constructor. So arrow functions don't have that secondary ability. Arrow functions are just functions, which makes things a lot more predictable. You don't have to worry about weird things. Now, one last difference between the two. So if I did another of an old school function, so function test, okay, there was this object that existed inside the function called arguments. It still exists inside classes. This is part of the whole class thing. It's part of the prototype thing. So if you were to pass a bunch of arguments into a class, you can still actually bring up this arguments object. But the object is called arguments. So even though I never actually defined any parameters, I could still access all that this way. Watch. Test 1, 2, 3, 4, 5, 6, 7, 8, 9. I passed in 9 arguments, and even though there's no parameters to hold those arguments in my function definition, I get this object, this weird arguments object that has all my arguments as objects. It's a little awkward to use because again, it's not an array, it's an object, so you'd have to like turn it into an array and then use it, or call each thing by its key. It's not the you could iterate over it, so you can use a for of loop. It is an iterable object, but it's just a little clunky. You can still use it with a class, so again, you can still do whatever, all that behavior still exists. Or you can just use this old syntax. But if I were to use an arrow function, so let's change this to an arrow function, const test equals, now it won't work because there is no arguments object. Pick the token, where is that? Const test equals, oh yeah, the arrow. There is no arguments object in an arrow function. Instead you get this weird thing. Okay, so there's an object called arguments, but it grabs all this stuff, and it's like, could you do anything with it? I don't know. So how would I want to, what if I did want to grab like an infinite number of arguments? You might have seen this earlier when I was talking about the template literals, but you can use the rest operators. So again, that 3 dots can either be called the rest operator when you're grabbing the rest of something, or the spread operator when you're spreading something. So in this case, we can just call this arguments, or we'll just call this args. So all my args will be in args. So this just grabs any arguments that come in and puts them in an array. So now in an arrow function, I can still do that, have an infinite number of arguments, but now they get passed directly into an array, which is a much easier place for them to work with. And again, I don't have that weird like double duty as a class prototype thing going on with my functions. So that's why arrow functions are so awesome. You still have the ability to do pretty much everything you could have done with a function, but what this is much clearer because it's never going to be the function itself. It's always going to be whatever invoked the function. We'll be referring to this. So if the function is invoked by a DOM element, it's the DOM element. If the function is invoked by a class, it's the class who's this. So this becomes just easier to understand. So that's the nice thing about arrow functions, why arrow functions are so cool. I think we have spent enough time on this. Trying to think if there's any other fun things to mention while we are here. No, that's pretty good. So I'll see you guys in the next video at some point. Have a good one, and ciao.